In this video, we're going to look at CRA models for whole number addition. So there can be two different types that we look at. And the first type of model is called a set model. So in a set model, we're measuring 0 dimensions, which means that we're just looking at the frequency or the count of objects that we have. So for our first example, for the concrete model, we're going to just look at our 10 frames with counters. So this is a model showing 6 plus 7. So if we want to add these, it means we're starting with smaller groups and we're going to combine them into a larger group. So with our 10 frame, we might first fill this up to see that we have 10, and we have 3, so 10 plus 3, so we have a total of 13. So that's a concrete model. For the set model. A representational model to go along with that would just be a drawing that looks similar to the structure of the 10 frames. You can have the 10 frames drawn. I just left them out here. But again, we can kind of do the same type of idea. You can take any of these 4 to kind of fill in this 10. So we're going to move these to this group on the left to start. So then our next step here is that we have this full set of 10, and then we have these 3 that are still remaining. So those need to be brought down and kept there. Okay. So then we're kind of viewing this as one entire group. This quantity of 10 and 3, or 13. Okay. And then our abstract model for this is going to be 6 plus 7. And we made this equal to 10 plus 3. If we wanted, we could, I kind of skipped a step in the middle there. We could rewrite this as 6 plus 4 plus 3. But this is that making 10 strategy. But just in the sake of space on the whiteboard, I left that off. So 10 plus 3, and I found that that was 13. Okay, so that's one example of a set model. This is going to be more for younger students, smaller numbers, since those 10 frames don't hold a lot of counters. So once we kind of increase in value, and this will kind of eventually lead us into some of our algorithms for addition. So another set model is a place value mat with our base 10 frames, or base 10 blocks. Okay, so again, these are just, it's a set model. We're not measuring the length or anything, the area. We're just counting how many objects there are. Okay, so kind of how this is eventually going to lead into some of the algorithms, like the standard algorithm is, right, we have this quantity, we have 3 10s and then 8 1s, so we have 38, and we have 2 10s and 5 1s, so 25. So we have 38 plus 25. We'll kind of want to replicate the same steps that we'll eventually use in the standard algorithm. So we'll start with our 1s column, and we'll regroup if we need to, and move a quantity from the 1s column to the 10s column if we need to. So I obviously designed this one to require that type of move. So we'll start with our 1s column. So we have 8 1s and 5 1s. All right, so how we can kind of think of this is, up here we have 10 1s and then 3 1s. Okay, so again, we're adding, means we're going to combine this into one larger group. These 10 1s, remember, we can only have a single digit amount in each column, in each place value. So we can regroup those 10 1s as 1 10. And the reason we can do that is because they're the exact same size, exact same quantity. Okay, so we're going to regroup or trade those 10 1s for 1 10. But then this piece no longer belongs in the 1s column. This needs to move over to the 10s column. So we've regrouped that set of 10 1s as 1 10. Okay, so now we can combine all of these pieces. We combine them into one group. So you can see we have 3 1s and we have 6 10s. So we have 6 10s, 3 1s, 63. So again, that's our concrete model. Representational model that would align with this pretty well is just going to be those base 10 blocks, but the drawing version of those. So again, you generally make these a little bit simpler, try to save some time, but students are hopefully able to know that these are representing those base 10 blocks. But we'll do kind of the same exact movement. So we have, again, 38 plus 25. So if I want to make one full 10, right, I would need to take 2 of these, right, 2 of these 1s, and move these over here. All right, so this is my Those are the ones that I've moved. All right, so I need to make sure I don't think those are still in that group over there. So I've moved those ones over to this other group of ones. All right, I want to add these. I want to combine these together. So then this whole set of 10 ones, we're now going to think of as a 10. Okay, so I'm going to redraw this just so we can see exactly what we still have. So I have still those 3 original 10s. And then this additional 10 that I just had regrouped. So I have 4 10s over here. And then over here I still have those 2 10s. And then I have 3 1s that are remaining. Okay, so here then I can just combine these. I don't need to do any regrouping. So I can take this entire group and just add this to that group on the left. So I had those 4 10s. I have 2 more 10s. So I have a total of 6 10s. And then I have 3 1s. And then for our abstract model, let's flip this over. So we had 38 plus 25. I'll break this one down and show the decompositions in this one. So what we turned this into was 30 plus 8. Right, because we were thinking about this in regard to the actual place values. 20 plus 5. So we have 30 plus 8. And then again, this is kind of the long drawn out version. You can take some shortcuts if you need to. And what we did was we thought of this as 5. We decomposed that even further to 2 plus 3. Okay, so I'm going to skip a couple steps in this just to speed this part up. Right, so then we would use our associative properties associative property and commutative properties. Right, the associative relates to how we're grouping different add-ins. The commutative property relates to the location of different add-ins. But essentially what we end up doing is we have 30 plus we did 8 plus 2, and we kept our 20 plus 3 over here. Right, so this becomes 30 plus 10, so this turned into 40 plus 20 plus 3. We added those 10s, so we got 60 plus 3, and then eventually we got 63. Okay. So if we wanted to, we could draw this whole process out a little bit more, or even make it a little more succinct if we would like. But that was kind of the abstract representation, again, just using our symbols and our numbers there. Okay. So those are both examples of set models because we're not looking at any other measure. Right? It's a 0-dimensional model, so we're just looking at the frequency. So the other type of model that we'll use for addition is going to be a length model. So this is where we actually have one dimension that we're measuring, which again is going to be the length. Okay. So a concrete example of this is just going to be our connecting cube. So I'm going to use the same problem that we did with our 10 frames and counters. So here we have just some connecting cubes connected together, some blue ones. So we have 6 right there, and we have 7 red connecting cubes. Okay, so when we're adding these, right, we want to combine them into one larger group. So we could do this in one move, right? If we knew that 6 plus 7 was going to be this total of 13. Right now this has a length of 13. We'd combine those. If we wanted to more model that making 10 strategy, right, if we have 6, we might know we need to decompose that 7 into 4 plus 3. First add our 4 so we can kind of track more easily that now we're at a length of 10. Then we can add on this length of 3 for a total length of 13. So that's our concrete model. Probably the most common representational model for a length model is going to be our number line. So when we have 6, we're starting at 6 here. And we want to add 7. So we're going to do jumps on this number line. We want the total number of jumps to be equal to 7. Okay, we'll see where we end on the number line. That'll be our total length. So we could add this one by one, just by kind of counting on by 7. If we want to more closely align with the making 10 strategy, right, first I might make a jump from 6 to 10. Right, so I've added 4 so far. I need to add a total of 7, so I need to add a little bit more. I need to add 3 more. So again, you can do 1, 2, 3, or you can just do that total jump of 3. Okay, so there we've added 3. So our total is that we have added 7. So we started at 6, we added 7. We ended up over here at 13. And kind of similarly to the 10 frame example, that abstract model, if we wanted to, again, if we wanted to align with this making 10 strategy, right? And I'll draw the more, or I'll write the more drawn out version of this as well. 6 plus 4 plus 3. All right, so we decomposed that add end of 7 into 4 plus 3, and then we're associating the 6 and 4 together. So then we get 10 plus 3. That is equal to 13. So again, with the addition, generally going to be using set models and length models. With the set models, we're just counting the frequency. So any sort of objects that you're counting, or base 10 blocks are good concrete models for that. And then drawings to align with those. And then with our length models, we're measuring one dimension, we're measuring the length. And the connecting cubes are pretty common models for those. And then number lines for the drawings are going to be pretty common as well.